Hello guys, today we are going to see the continuation of central force motion. If you didn't watch the part 1 video, go and check it out. I will give the link in I button. Today we are going to see differential equation of orbit. This is very important topic in exam point of view. So many numericals are come under this topic. I am not going into the derivation because that is not important here. We are going to memorize the differential equation as it is. Del square u del theta square plus u is equal to minus m f of r upon L square u square. So this is the differential equation of orbit. Here L is going to be m r square theta dot. Everything we are going to write here. Okay. Then u is equal to 1 by r. Here r is given to you. A function of force f of r is given to you. So in question the function f of r is given. You have to consider u is equal to 1 upon r. In the differential equation, we have to substitute the value of del square u by del theta square. For that, you have to differentiate u value twice. So let us solve one question so that you will get a clear-cut idea about how to solve this differential equation of orbit. Here we are going to solve the equation of an orbit of a particle which is moving under central force of a particle which is moving under central force, that is r power n is equal to a cos n theta. So we have to find force law of this orbit. So here r is given in the question itself. So r power m is equal to a cos n theta. Then let we consider the value of u, that is here u power n is equal to 1 by a cos n theta. That is, we know that u is equal to 1 by r. 1 by cos n theta is equal to secant n theta. Here comes the tricky part. We cannot find del u power n upon del theta directly by using the direct relation, so that we have to take log on both sides. So the third step is taking log on both sides. So we get n ln u is equal to ln 1 by a plus ln secant n theta. After that we have to move on to fourth step, that is we have to differentiate the previous equation with respect to theta. N ln u will become 1 upon u. Again we have to differentiate u with respect to theta, that is dou u by dou theta, that is equal to a is the constant, so the differentiation value is 0. The ln secant n theta will be differentiated as n by secant n theta into secant n theta tan theta. We can cancel out secant n theta, so the equation becomes n by u dou u by dou theta is equal to n tan n theta. We are doing all these steps to find out dou square u by dou theta square value. From this equation we can find dou u by dou theta. So that is equal to u into tan n theta. After that we have to find dou square u by dou theta square to substitute that value in differential equation of orbit. So dou square u by dou theta square can be found out by uv differentiation method. Dou u by dou theta keeping tan and theta same plus keeping u value, then differentiate tan and theta. The differentiation of tan and theta will be n secant square and theta. Here we can substitute dou u by dou theta value, that is u tan and theta, keeping all other terms same. Finally, we found out the value of dou square u by dou theta square. We have to substitute this value in the differential equation of orbit. So by substituting that in differential equation of orbit, we get u tan square n theta plus un secant square n theta plus u is equal to minus m f of r upon L square u square. After that, we are taking u common in first term and third term. So we get u 1 plus tan square n theta plus un secant square n theta is equal to minus m f of r by L square u square. From this equation, we can write force F of r is equal to minus L square u cube into 1 plus n secant square n theta divided by m. So 1 plus tan square n theta will be written as secant square n theta. So taking secant square n theta common, we get 1 plus n. After that, we have to substitute the value of u. For that, we know u power n is equal to 1 by a secant n theta. Taking squares on both sides, we get secant square n theta is equal to a square u 2 power n. So we substitute this value in the force function f of r. So we can write f of r is equal to minus L square u cube 1 plus n. Instead of secant square, we can write a square u power 2n by m. From this, we can conclude that force function f of r is directly proportional to u power 2n plus 3. By combining the powers of u, we get u power 2n plus 3, so that the force function is inversely proportional to 1 by r power 2n plus 3, because we know that u is inversely proportional to 1 by r. So if the function r power n is equal to a cos n theta is given in the question, then we can write the force function is equal to 1 by 2 r power 2n plus 3. This is the trick. We can also note this in your formula notebook. If r is equal to a cos theta, we can write n value is equal to 1. If r is equal to a cos 2 theta, then n value is taken as 2. For the first case, the force f of r is inversely proportional to r power 2 into 1 plus 3, that is 5. We have to substitute the value of n in the first formula. For the second case, we can write 2 into 2 plus 3, that is 1 by r power 7. So these are the tricks we can also use to solve these questions in seconds. That's all for today's video. Thanks for watching. I hope all the concepts are clear. If there is any doubt in this topic, comment below.